And we are live. What's up, guys? And welcome back to another episode. I got a special guest for you today. I got Hunter Prendergast, which is a former nuclear reactor operator, solar system designer, and computer engineer who has been working with blockchain technologies since 2015 prior to co-founding MIMIR. That's how you pronounce it? How was it again?
MIMIR.
MIMIR, which is a Norse god, right?
Yep, that's correct.
That's awesome. We'll get to that in a second. And to build secure hardware devices, deployed automated trading algorithms, and research alternative applications for the Ethereum blockchain. Hunter, welcome to the show, and thank you so much for doing this. You and I originally connected a couple of weeks ago. Unfortunately, due to timing restrictions and things out of our control, we couldn't do the podcast at that point. But the reason why I wanted you on the show is I had questions about the Parity hack and what went down, how did it go, and also kind of expand on that is like, since we have all these platforms and wallets out there and smart contracts holding ridiculous sums of money, what are we implementing in place for actual security protocols or audits to make sure this doesn't happen again?
Absolutely. Yeah, there's a lot to talk about in those spaces and how we should be done better, how we can change the system to accommodate both the user and the business or wherever the security need lie, really. So where did we want to tear in to start all of this?
Well, why don't we do kind of high level approach or kind of a scan of what happened with the Parity issue?
Okay. Well, the Parity wallet hack really came down to a mistake. So when they deployed the Parity wallet itself, they created a library, and then they were using what's called a proxy. And proxies are basically a very minimal contract that allows you to talk to another contract in any way that you want. And what this does is every time someone would create a new wallet contract on the blockchain, they wouldn't have to pay nearly as much gas because all of the complex logic that allowed the wallet to operate existed in this library contract that all of the proxies were calling into, and they shared the same logic inside of that library. Now, every time that they did a change, what was actually occurring is they were changing the copy of their own local memory space in the contract system. And so what ended up actually happening was, because of a mistake during the programming of the library contract, it enabled a hacker to really go in and, while just kind of fiddling around, it would appear, accidentally destroy the entire library. And in the process, because all of those proxies relied upon that library to actually perform their logical operations, he effectively seized, I mean, I've heard various numbers, anything from 150 to over $300 million by accident. And then with the recent changes in price, substantially more than that now. So that's kind of a fairly high level, but kind of technical at the underside. So where's any confusion points you had on what I said?
No, I'm quite aware of that. And I understand that. My next question would actually be is two things. A is, how can we stop this from happening again? And B, we can't guarantee that stuff like this won't happen again in the future. What better, let's say, contingency plans can we create to offset if this happens again?
Well, first we'll start with the contingencies. So there is actually a proposal within the Ethereum development community to essentially have the ability to reset all of these types of things that may occur without actually having to perform a fork. And so this would take place through a consensus mechanism. And I don't think all of the details are really fully vetted yet. But essentially, it would allow you to have the community as a whole roll back and undo these types of unintended things without having to modify the protocol itself. So that's one mechanism. There's, of course, with anything of that nature, what we call the problem of the commoners. You know, you hear the analogy of the commoners robbing the coffers. So there's security concerns, and this is one of the things that must be balanced in that system. And so that's why we haven't seen that proposal probably go through, although it would help with a lot of this stuff. The other way that's really coming about to mitigate these types of circumstances is using virtualized ether tokens. And so this is actually a mechanism that we're employing within our own system, is the ERC token, ERC20 token contract is a very well-established, like, secure piece of code that everyone uses. And what you can actually do with it is you can have someone send you Ether, and then you can give them an IOU in place of that Ether that they gave you. And the idea here that's really interesting is that if you go send around all of this virtual Ether, if something goes wrong, then all that you really have to change to make it work, or to undo a horrible accident, is to change a single contract and rewrite some numbers. This is awesome because we could undo some things, but just like the other compromise I was talking about, that's only one place that someone has to rewrite some numbers to steal all of the Ethereum. So using virtualization is beneficial in that you can kind of undo it, but it's also dangerous. So those are the two mechanisms to kind of, you know, fix once this has happened. Now, in terms of mitigating this from happening in the future, there's a lot of things that are in proposals. One of the more exciting ones that I really look forward to actually hopefully happening would be to get WebAssembly support inside of the Ethereum EVM. And the reason that I say this is doing deterministic code, provable code, so basically writing something and know that it's only going to do exactly what you intended it to do, is much easier in that language. So there's potential there. There's also a number of developing tools for doing security audits against your own smart contracts. But I think within the Parity wallet hack, one of the things that really you should keep in mind is this is the second sequence of hacks against this wallet that this company had created. The revised copy of the new wallet came out within, I believe, 72 hours of the original hack occurring. The question is, did they really audit this code as much as they should have before they went live with it again? And so that's the thing at the end of the day is, if you want to prevent these types of accidents, you have to know that what you've written is accurate and it's going to do what it should do in the way you want it to do it.
Did you see their statement? They actually came out, I think it was yesterday or the day before yesterday, talking about hard forking.
You know, I haven't read the statement because I'm actually right now turning on the alpha for my own company. So I'm embedded in code almost all day long and sleeping like 4 and 5 hours a day. But I'll get around to reading that one soon. I think that that's probably the only way that we can expect to get these funds back, though, is a hard fork.
But then that brings up the question, though, of like, because a lot of people see Ethereum as, well, they try to compare it to Bitcoin, which is not, but they see a store of value. Some people do. But the whole idea, if we can then constantly be hard forking these circumstances, then who's to say which circumstances should get approved or not?
Well, mind you, I didn't say that I necessarily agreed that we should hard fork, but I just said that that's the only way that we could get them back. Now, I agree. I think that continuously forking, if we look at the economic incentive in the system, right? The economic incentive is for a few minority miners to hang on when a fork occurs. And if they can get enough of a community to stand behind them, then they effectively permanently forked the network, or at least temporarily. And they're on a network that, albeit has a much higher difficulty, has way fewer people on it. So they're going to get a lot more reward. If you just think about the raw numbers of the economics, if you do these types of protocol upgrades, the game theory is pointed at people should try to leverage that game. If you just do the equilibriums or the Nash equilibriums. So it shouldn't be unexpected that that's going to happen. And it does destroy the value of the network if it happens too many times. So I think with all of that said, that yes, we should be very, very careful how often we hard fork.
Is there any ways we can like mitigate this stuff on the back end, having some kind of multi-sig variations?
Well, I mean, explain exactly what you're asking there, because.
Okay, so in the Parity hack, right? They had one set of a library was relying on another set of code, right? And this hacker with this individual, we don't know exactly who this person background is, He came in and he found this faulty default and changed a bunch of stuff, and there you go. The code is suicide, or whatever they want to call it. Is there ways that we can create where not just one person can come in and do something that where even if he or she does do something like that, it automatically triggers an event or notifies other, let's say, participants within the security network?
So there's actually a really great paper on this exact topic that I recently read. And this is a classic engineering solution. It's not a very efficient one, but it is an interesting one, which is, say we're going to send, and a little bit off topic, but bear with me. Say we're going to send a rocket into outer space, right? Mm-hmm. If something goes wrong, it's catastrophic. One of every system. Two of every system then fails, we can keep the rocket in the air, right? So the classic engineering solution is, well, hey, if 2 is good, 3 is better, and et cetera, up until how much can we shove on here, and then that's where we stop. Mm-hmm. So there was a paper I recently read that actually was, the idea was you take 2 or 3 individual groups of programmers, and you give all of those programmers the specification for what you want your program to do. And you have them completely isolated and code all of the logic to perform the contract. And then you have to, in this case, use 3 groups actually. But then at the end of the day, anytime you want to modify something inside of the contract, you actually call all 3 of the contracts and you get the consensus of the 2 out of the 3. This way, if any one group made a mistake, then the other 2 groups hopefully would not have made the exact same mistake. And you could catch some of this. So yeah, the multisig kind of idea extended up and abstracted into the application logic layer. People are talking about it, but the gas cost of running that,
yes,
it gets expensive, right? So it's a balance, as everything in engineering.
Do you see big issues or fears in your mind with all these ICOs and people just running around with copy paste code that no one has really audited or taken time to really work on?
Well, I think that most of the people who are doing copy paste code, they're probably not going to be writing some complex logic, and they're not going to be building some intricate machine. They're probably just going to take the ERC20 token interface and they're going to cut and they're going to paste it into a page, and they're going to go, man, I just made some new money for the whole world and I'm rich, and it's a great day, right? Well, I think that contract is pretty secure. I mean, I've audited it a lot myself because we're using some of the logic in pieces of our system, obviously, and there's only one flaw that I'm aware of in that code, and it's a race condition for front loading, essentially.
Yes.
And that is, for all practical purposes, an acceptable flaw because it's actually doing something as intended. It just, with a little bit of tweaking, you can make it do it better. So we've tweaked out ours just a tiny bit, but you can't change it much or you break anyone who wants to interface with your system. So to go back to the original question, am I concerned? Yes, I am concerned about people flippantly raising millions of dollars that don't necessarily understand cryptography. That scares me a lot, in fact. But I'm not scared that the ERC20 token contract is what's going to cause the problems. I think it's going to
actually, you're right. You know what scares me the most in this space is the exchanges.
Yeah, I mean, isolation and, or rather not isolation, consolidation of massive amounts of funds.
Can you imagine like Bittrex or Kraken if they got hacked as of today and everything got liquidated?
Well, I mean, it would destroy the markets.
Yeah, it would.
I mean, it's an interesting problem because even if you could break in as a hacker, would you want to empty the bank account or would you want to trickle off bit by bit so that you didn't destroy the market you're robbing, right?
Because then you have skin in the game once you rob it, right? You don't want to lose the value.
Exactly. Yeah. The beautiful thing of you know, how blockchains work on economics. So yeah, it is terrifying. And there's a lot of things that hopefully those companies are doing. I don't necessarily know all of what they're doing underneath in their server-side logic, but I would hope that they're using secure hardware devices and really doing the things right, because they have some of them, if hundreds of millions, if not billions of dollars potentially passing through their system frequently.
So what's your, I'll ask you two questions. Question number one is what excites you the most right now in the space? And then we'll follow up with what is the most concerning for you in the space?
Most exciting things in the space. I think that really the thing that excites me is actually seeing some of the projects start to turn online, and we're starting to see these concepts that people were talking about, you know, decentralized exchanges, atomic swaps across chains, micro channels, all of these things that everyone's kind of been looking at and going, hey, if we could just turn these pieces of logic on, we could take this from something that's incredibly useful into something that essentially rivals payment processing systems on a global scale. And that to me is the transformation when the blockchain goes from being essentially DARPANET of the 1970s, early 80s to the internet of today, where it's a global communication and exchange platform that is integral to almost everyone's daily lives, even if they don't know it's there. That, if that makes sense, that's what I'm really thinking is where we're moving in the future, and I'm hoping I'm right. But the things that scare me the most right now, I'd say that the most scary things to think about are upgradable contract logic and people doing it wrong, and why it's necessary, and why, you know, this whole thing of you write a smart contract and you are guaranteeing that the logic of the contract is established, because that's what smart contracts are intended to do. But then when you look back at that problem and you go, well, wait a second, what happens when a bug does occur? We need a way to modify this. So then you put in a mechanism by which you can modify a piece of code. Well, now have you accidentally given yourself a back door, right? Or given someone else a back door, or put in something that allows someone else to destroy your entire system. So I say that this is the thing that scares me the most. Maybe it's just because I've been writing a lot of Solidity recently. And even unfortunately, what I don't like having to do at places had to go into some assembly, which means that you have to really audit what you're doing. And so finding this balance between mutability and security is something that scares me personally. And it also scares me because if we have people who are trying to do this that don't understand how to construct finite state machines and do it right, it could undermine and destroy the entire thing that so many people have worked so hard to build up.
Do you think like second layer solutions, for example, like Plasma or generalized state channels, can kind of like mitigate a bunch of these issues?
It depends on which issues. I mean, which ones do you think that they can mitigate? And then I'll give an opinion on that. How about that?
All right, let's do a real case study. If we had Plasma or if we had generalized state channels, could it mediate any issues that happen with Parity? If Parity used those second or third layer protocols on top of Ethereum?
Well,
if they use them.
Yeah, if they use them. So if we were using second layer protocols, it's an interesting question. One, honestly, I haven't thought about a whole lot. If we make the assumption that payment processing could occur outside of the traditional wallet scheme, it could have prevented having so many people putting money into that wallet. That would have been something of value and utility. The use of these micro channels, the fact that they are off-chain, which means that they're potentially mutable. If you could develop a side channel consensus mechanism to kind of remove the counterfactual claims or the protections in the system to be able to undo a wrongness.
Yeah.
Yeah, I think that definitely if you're off chain, it's easier to mutate data. Now, what you really have to wonder is not necessarily if it's possible to mutate the data, but if it's possible to coordinate the human beings in such a way that it's in their best interest to actually observe the rules for mutating the data.
Yes.
And that, I don't know. Because people move wherever you put the carrot, right?
Oh, totally. And that's the whole thing. Like even my concern moving on to like any proof of stake model, whether it's delegated proof of stake or whether it's Casper's with sharding, is how do you stop coordination attacks? How do you stop collusion? How do you stop the fact that like if I can out even financially I just outmaneuver you, because if I'm staking say $1 million worth of ether, I have more say than you do.
Yeah. So this is a problem within weighted proof of stake schemes because you have the ability to be a whale and to kind of shove the market around. Now, the same question exists for miners, though. And with that said, miner manipulation, that's a fact. I mean, we've seen examples of suppression of block size actually by mining.
Spamming the network. It was just a couple of weeks ago. The mempool in Bitcoin got flooded.
Yeah, we've also seen. I mean, we've seen all kinds of stuff. Even some of the gambling contracts. You know, they are essentially manipulating randomness and front running all kinds of stuff. So yeah, people will go wherever the money is, and so miners have potentially the ability to do the same thing you're describing in a proof of work system as you could in a proof of stake system. But manipulating the system too much is in your disinterest, right?
Yes.
It's just manipulating it enough that you don't hurt the thing. Be parasitic. Don't kill the thing. Just kind of live on it forever, right? Like that's the way that these people have to live. I'm just looking at it from a technical standpoint.
Yeah.
I don't agree with that opinion, but if you're looking at the game theory now, within proof of stake, yeah, I mean, you can manipulate it. So you have to be careful.
What's your thoughts on that, the delegated proof of stake, where you have delegate, I think it's 21 masternodes for voting?
You know, I haven't done the math on the game theories, and I haven't thought through all of the different games or strategies you could play. I will say that it's a pretty complex game, right?
It is. This is my big issue with this, and I'm just going to make it a parallel with voting in politics. It's okay. Like anything in politics, you can bribe politicians. A lot of human beings are bribable. That's one issue. But the bigger issue is this issue for me. Maybe they figured it out and I just don't know. The voting turnout for voters, what do you think? It's like, what, 50%, 60%? It fluctuates, right? It's not 100% of people come out and voted like, yeah. So the way that these delegated masternodes get voted in is like everybody comes together who's a token holder, like, I vote this as a masternode. Well, guess what? You're not gonna have 100% voter turnout. So you're gonna have all these whales that have all these tokens are gonna manipulate who these masternodes are, and obviously they're not gonna manipulate the nodes to decrease the value of their token. They obviously want to increase the value of token, but they have say over what consensus happens in that ecosystem.
Yeah, we get back to the centralization problem all over again, right?
Yeah.
And I think that you're right. I think that consolidation of power into too few individuals in a system that's as large as, you know, cryptocurrency networks are today, it's dangerous, and it needs to be played out very carefully. And when it comes to basically me saying it was a complicated game, the more simplistic you can make the game, the better off you are, because a great example of this, the system that we are building within the product my company is working on uses a proof of stake mechanism under the hood. We had developed our product for, I believe, almost 2 months. And I was sitting outside with one of my software designers or software architects, and we started kind of playing out a game, basically playing through the sequence of the proof of stake model. And both of us looked up about halfway through the game and went, oh my God, we missed that strategy, and it destroyed everything that we'd been working on. And so we, you know, panicked and looked at each other and said, all right, we've got to undo this. We've got to fix this problem. And we went back to the drawing board and we proceeded to redesign the underlying game theory to make sure we observed the edge case that we'd forgotten about. That's the point, though, is if you forget one of the edge cases, and if we had made our system with that edge case in it, it would have essentially put a gaping hole in our security model. So keep it simple.
Keep it simple. So why don't we kind of expand on that? Like, what are you guys actually working on right now, or about to launch actually today? You said.
Well, it's not going to be launched today. We're in the process of, you know, doing some load testing and just
load testing. Yeah.
Everything is coming up gracefully and doing what it's supposed to do. So we're making sure all of the bugs are out of the system. We're going live on alpha next year. The product that we've been building is a decentralized web API. So if you know what web APIs are, I'm sure. Yeah. Yeah, so obviously a way for mobile devices or devices that are resource constrained to access the blockchain. You know, that could be IoT, that could be cars. I mean, anything that has a connection to the internet that might have some utility in knowing something about the Ethereum blockchain. And so we're building a decentralized web API, which means that instead of hosting all of our own nodes, we rely on the fact that there are currently 25,000 nodes in the world, approximately, on any given day. That is an immense amount of processing power that's already dedicated to the very problem of having stateful information about the blockchain. So the idea is that running a node in a cloud infrastructure is very expensive for bandwidth, for processor, for storage, all of these things that go into it. So we offload our cost of running that infrastructure into the Ethereum community and pay people to do something they're already doing and give people the information that they need on these mobile devices or resource constrained devices.
So your platform's pretty open then for like devs to go on there with your open API.
That's the entire idea. Is at the end of the day, it should be as easy as binding to an RPC node on your local host, right? It should be a nice transparent pipe for devs. We're really not aiming at this product at clients. I mean, clients will obviously use it because they interact with the blockchain too. It's when I say clients, I mean like individual users. We're trying to build a tool that makes developers able to extend the reach of what they're making very easily and very inexpensively.
That's awesome. You said next year at some point you guys are live?
We're going to go live on Ropsten January. And
oh shit, around the corner.
Yeah, right around the corner. We've been mining pretty heavily on Ropsten. So if you notice, there's like 4 or 5 addresses that are always winning. We pointed some huge GPUs at it so we can turn on a faucet, and we'll be turning out some ETH from our faucet for the alpha testers, and we'll be turning out the tokens that will be utilized in the proof of stake model of our system. And we'll be running through the game theoretics and making sure that everything is running the way that it should. Because I would much rather do that with the Ropsten testnet than with the Ethereum network itself.
And where can people check this out?
So our website is MIMIRblockchain.solutions, and you can get a lot of the information and resources regarding some of the upcoming releases. We're still limiting some of the information we're putting out until we're positive that we have everything where we want to be for next year. But we're going to be going live and letting people play with the API soon.
That's awesome. Well, Hunter, I just want to thank you so much for coming on and sharing your knowledge with everybody. And I'll speak to you soon.
Thank you very much, Amir.
Take care.